All right, let's dive into the world of polynomials. You know, those graphs with all the wild twists and turns that can look pretty intimidating. But what if I told you there's a really simple rule, kind of like a secret handshake, that lets you predict where even the most complicated looking curve is going to end up? Well, today we're going to unlock that secret together. So first up, we're going to unlock that secret. I'm going to show you the surprising connection between a simple, straight line and the crazy behavior you see in some of these polynomials. And it all boils down to one powerful idea, the opposites rule. So just take a look at these two graphs. On one side, you've got your everyday, predictable straight line. And on the other, you have this winding, complex polynomial curve. I mean, they look like they're from different planets, right? But believe it or not, they share a fundamental secret about where they start and where they finish. Any guesses what that could be? And here it is, the odd degree rule. It's actually beautiful in its simplicity. All you have to do is look at a polynomial, find its highest exponent, that's what we call its degree, and if that number is odd, like 1, 3, 5, whatever, then you know one thing for sure. Its ends have to point in opposite directions. One side is going to shoot up forever, and the other is going to go down forever. Seriously, there are no exceptions. Okay, but we can get even more specific. The direction it goes depends on just one more little thing, the sign of the number out in front of that highest exponent. If it's a positive number, the graph acts just like a line with a positive slope. It starts down on the left and goes up on the right. And if that number is negative, well, you guessed it. It's just like a line with a negative slope. It starts up on the left and finishes down on the right. See? It's really that intuitive. So you're probably wondering, why does this work? Well, it's not magic, it's math. The whole secret is that odd powers, multiplying a number by itself an odd number of times, they always preserve the original sign of that number. A negative number stays negative, and a positive number stays positive. Let's just look at this in action with some big numbers. If we plug a huge negative number, like -1,000, into an odd power, like x cubed, the result is a gigantic negative number. But then, if we plug in a huge positive number, the result is a gigantic positive number. The sign stays the same. And that's exactly what forces the two ends of the graph to go off in opposite directions. All right, theory's great and all, but let's actually put this rule to the test. We're about to see how this whole thing builds into a super simple, repeatable process you can use for any odd degree polynomial you see. Okay, check out this first example. Yeah, we've got a jumble of different terms, but here's the pro tip. We only care about the one with the highest power. That's x to the fifth. So step 1, is the degree odd? Yup, 5 is odd. Is its coefficient positive? Yes, it's a positive 1. Step 2, apply the rule. Positive odd degrees act like a positive line. So step 3, the conclusion? Simple. The graph starts down on the left and ends up on the right. Done. Let's run through another one real quick. Here, the highest power is x cubed. So step 1. The degree, 3, is odd. But look, this time the coefficient out front is -2. Step 2, we apply the rule for negative odd degrees. And step 3, we know immediately, without doing any other math, that this graph is going to start up on the left and end down on the right. You see the pattern? It's such a powerful shortcut. Okay, you've got the basics down, so it's time to level up. Sometimes polynomials are written in a way that's kind of designed to trick you. In this next part, we're going to learn how to spot those hidden clues and avoid some really common traps. This right here, this is one of the oldest tricks in the book. It looks so innocent, but that little factor, 3 minus x, is designed to catch you completely off guard. Let's break down exactly why that is. Okay, here's the whole function, all factored out. First, let's find the degree. We've got 3x terms being multiplied together, right? So x times x times x gives us x cubed. The degree is 3, so it's odd. Now, here comes the trap. Step 2 is finding the sign. The first x is positive. The x in the last part, x plus 2, is also positive. But look really closely at that middle one. The x inside 3 minus x is actually negative. So we have a positive times a negative times another positive, which gives us an overall negative sign. And the conclusion? It's an odd degree with a negative sign, which means it has to go up on the left and down on the right. And this brings us to another huge point of confusion. I hear this all the time from students. Wait a second, if the leading coefficient is positive, shouldn't the whole graph just, go up? And look, it's a totally logical question, but it's based on a misunderstanding of what positive really means here. So let's be absolutely crystal clear. For one of these odd-degree polynomials, a positive leading coefficient does not mean the graph is always above the x-axis. No way. It can dip below into negative territory plenty of times. What it really means is that the graph is generally increasing as you go from left to right. And here's the crucial part. It starts low and it ends high. That's the main takeaway.
So why are we spending all this time on end behavior anyway? Well, it's because this isn't just some abstract exercise for your math class. This rule actually has some really big implications for how we can model things in the real world.
I mean, think about it. Odd-degree polynomials are perfect for modeling any system that has to make a complete transition from one state to another. You could be talking about a company that starts with a financial loss but eventually turns a profit, or the price of a stock that goes up and down but has a clear overall trend. These are all real-world situations where one end is down and the other is up. And this is the most powerful guarantee of all. If a graph absolutely has to start down in the negatives and end up in the positives, what does it have to do somewhere in the middle? It has to cross the x-axis. It must pass through zero. The opposites rule literally guarantees there's always at least one real solution, one x-intercept, one break-even point.
You know, this guarantee is so fundamental, it actually has a famous name in higher-level math, the intermediate value theorem. So by understanding this simple rule about opposites, you're actually taking your first step toward grasping some of the most powerful ideas in calculus and beyond. So we'll leave it with this thought. We just saw how a simple rule about exponents can give us an absolute guarantee about how a graph behaves. It kind of makes you wonder, if end behavior can offer a guarantee like that, what other certainties are hiding in the language of math, just waiting for us to find them?